Hello friends, welcome to my channel. In today's video, we will see what is bubble sort, how we can implement bubble sort using Java, and what is the time and space complexity of bubble sort. Bubble sort is a sorting algorithm which is used to sort the elements of array in ascending or descending order. In this video, we will see for ascending order. First of all, let's create an array. We have, let's say, element 5, 2, 6, 0, 1. Right? So this is an array. According to ball sort, we need to compare the adjacent elements of an array, and if this element is greater than this element, then we need to do swapping. Okay, so swapping is an important operation which is involved in ball sort. Okay, so let's say if we take j as a variable, right? So the condition will be like, if array of j is greater than array of j plus 1. If this condition satisfied, then what we'll do, we'll do swap, right? Yeah. So we'll see here, since 5 is greater than 2, right? So swap will happen here. So after swap, our array will look like something 2, 5, 6, 0, 1, right? Again, we have come up to this index, right? Now we have to compare 5 and 6. Since 5 is not greater than 6, no swap will happen. Okay, then we will move forward. We'll compare 6 with 0. Since 6 is greater than 0, again we need to swap, right? So after swapping, the array will look like 2, 5, 0, 6, 1. Now the index has come up to this element. Now we will compare 6 to 1. Since 6 is greater than 1, again what we need to do is swap, right? So after swapping, we'll get array which will look like 2, 5, 0, 1, 6, right? Now if you see here, right, the heaviest element has been popped up and it has come in the last, right? Now you need to sort array up to this, because this part is sorted, right? So this whole thing was the first iteration, right? So in the first iteration, we just saw the adjacent element of each element and compared with it, and then if swap was needed according to this condition, right, we did the swapping. Now we will move towards the second iteration. Okay, second iteration. Our array was something like this: 2, 5, 0, 1, 6, right? So again we will compare 2 with 5, but since 2 is not greater than 5, there won't be any swap. Again we need to compare 5 with 0. Since 5 is greater than 0, we need to swap here, right? So after swap, the array will look like something this: 2, 0, 5, 1, 6, right? Again we had come up to this index. So we will compare 5 to 1. Since 5 is greater than 1, again we need to swap. So after swapping, the array will look like 2, 0, 1, 5, 6, right? If you see here, now the second heaviest element, which is 5, right? Now array is sorted up to this, right? So now we need to sort array up to this element, right? Now again we need to do the third iteration. Third iteration. In third iteration, our array was looking something like this: 2, 0, 1, 5, 6, and array is already sorted up to here. So we need to navigate J from 0 to second element, right? Again, we need to do the comparison. We'll compare 2 with 0, right? So since 2 is greater than 0, here we need to swap, right? So after swapping, array will look like 0, 2, 1, 5, 6, right? Again, we need to compare 2 with 1, right? Since 2 is greater than 1, again we need to swap. After swap, the array will look like something this: 0, 1, 2, 5, 6. Okay, so this iteration is also done. So you need to see whether the array is sorted or not. You need to again make one more iteration, right? So we'll do the fourth iteration. So in fourth iteration, we have array 0, 1, 2, 5, 6, right? So we will compare each element, right? But since the previous element is not greater than the next element, there won't be any swapping, right? No swap will happen. That means our array is sorted, right? So here we saw that in each iteration, whatever the heaviest element, it will get sorted. So in first iteration, we saw X is sorted, right? In second iteration, we saw this 5 and 6 is sorted, right? In next iteration, we saw 2, 5, 6 is sorted. So it progressed like this, right? So basically, iteration will go from 0 to n minus 1, right? This is iteration. And the comparison that we are doing, right, which is the inner loop. So that will go from 0 to n minus I minus 1, right? Why this n minus I minus 1? Because in each iteration, if you see, right, so in the first iteration, this element got sorted. So now we don't need to, in the next iteration, we don't need to traverse to this array because it is already sorted. So we have to take care of elements up to here. Similarly, on the next iteration, when I is 1, right, this 2 got sorted, right? So in each iteration, if you see, one element is getting sorted. That's why we need to subtract this I from n minus 1, right? So this is the inner loop. So here I have already created one class which is ball sort. We'll create one main method, right? So what we need to do is first we will create one array, right? So let's create one array equals to, then give some element. Let's take the similar kind of element 5, 2, 6, let's say 1, 0, right? So this is the array, right? Now we need to sort the array and then we will print the array. For that we will need two different methods, one for sorting and one for printing the array, right? So we'll create two different methods, public static void, and let's name it as bubble sort. Okay, and it will take input as an array, right? Similarly, we'll also create one more method, name void, let's put as print array, right? It will also take input as array, so it will print the array. Here we will call bubble sort method. In this we'll just pass our array, then we'll call the print array method and pass array to it. Okay, now let's write the bubble sort. So as I said, right, in bubble sort we will have two arrays. As I said, right, in bubble sort we will have two loops. One will be for iteration and second will be traversing through the array, right? So we'll create two for loops. One for loop will be for iteration. So we'll just write for int I equals to 0. I will be less than array dot length minus 1 dot length minus 1 I plus plus, right? This is the first for loop, and then we will have second for loop which is for traversing through the array. So we'll take int j equals to 0 and j will be less than array dot length minus I minus 1, right? Why I have done array dot length minus I minus 1? Since in each iteration, whatever the heaviest element will be, it will get sorted, right? So we need to subtract minus I to avoid unnecessary iterations through the array, right? And then j plus plus, right? Now again we need to just compare if array of j is greater than array of j plus 1, then we need to do what? Swap. We need to just swap the elements, right? So swapping, how we'll do, just we'll take on temporary variable in temp. In that we will store the array of j, right? And then into array of j we will put array of j plus 1, right? And in array of j plus 1, we will put the temp, right? So this will basically swap the two adjacent element. Okay. Now we need to little bit optimize our code, because let's suppose if array is already sorted, right? So then we don't need to iterate through n minus 1 times, right? So to avoid that, what we can do is we can just use one variable. So let's say we use boolean is sorted. So if array is already sorted, we don't need to iterate till n, right? In one iteration only, we will get to know that array is already sorted. So I've just taken this variable is sorted and we'll just assign false value to it. And for each swap, what we'll do is sorted equals to true. So if any swap happens, right, this is sorted variable will be true. But if no swap happens in a iteration, right, then this is sorted variable will be false only, right? So after this for loop, what we can do is we can just check if is sorted equals to false. That means there is no swap in iteration. That means it is already sorted. So what we need to do is we need to break so that there won't be any unnecessary iteration, right? So this is here. Now we need to print the array. So simply what we'll do is we'll just loop through the array for int I equals to 0, I less than array dot length I plus plus, right? Then we'll just do s out array of I, and we will just add one space. Okay, so this will print our array. Now let's execute our code and see if array is sorted or not. It is parsing the code. So if you see here, right, array is sorted. So what I will do is I will just remove the println, and again I'll run the code. Okay, so now if you see, right, array is sorted 0 1 2 5 6. So this is how you can implement ball sort in Java. Now if you see here, right, the time and space complexity. So since there are two for loop, one is for iteration and one for traversing through the array, there are two for loops involved. That's why the worst case time complexity of all sort will be n square. But if array is already sorted, right, then we don't need to do multiple iteration to n. In one iteration only we'll get to know. So the time complexity will be O of n in best case scenario. So that's all about bubble sort. Next we'll see insertion sort.